Okay, so we're going to move on to a specific example, the ECB 300s for RL20, because this system's already all set up and running, and you can interface with it pretty easily. So you guys don't really have to worry about this. We can go over that in another meeting if you guys want. Just the code for that device. It's not too important for this meeting, scope of this meeting. What's a little bit more important is the heartbeat. We set up a heartbeat so that we know we're communicating correctly to this device. We're both sending and receiving a heartbeat for this device. And these are the inputs and outputs that we're going to be sending and receiving from Delta V. We're getting almost no readback from this RL for some reason. So we get a fan speed from Delta V. We get a damper command. We get a temperature set point. We get a temperature deadband. We get a heartbeat from Delta V. We're sending it a temperature and a heartbeat ourselves.
How is this different than the page we looked at like 4 pages ago where you had Delta V inputs and outputs? How's that?
It's not, except this is a VAV and this is an ECB. That's the only difference. Good question. And this one actually has one more output than the others because this is 4RL20 BE5. So this is one of the end ones on that RL20, which has an extra temperature. The two in the middle, they would not have this. They would just send it a heartbeat. That's it. Very simple. Okay. So now we're going to dig down into how to point the bacnet points to the modbus points. It's probably the most critical part of this meeting. So in each device, as you can see, we're in the station. We're in the drivers section. We're in the BCP bacnet driver specifically. In that drop-down menu, there are those devices, which we saw right here. All of these devices will be in that drop-down menu. So we are there now. And in each device, it has a points section associated with it. You double-click on the points section, it brings up the points. Now, these points were pulled in, that there was decisions made by Christy Fritz and minorly myself about what points to pull in from bacnet to this ECNet 4 Pro. So we're pulling in a smoke detector, a Delta V heartbeat, this type heartbeat, temperature set point, temperature deadband. We're pulling that all in to that ECNet 4 Pro. And to do that, we had to discover the points, and the points available to pull in were all of these blocks. Any one of these blocks, we could have pulled in. But we have to manually go in and select which points that we want to pull into ECNet 4. Otherwise, it would just be a waste of memory if it pulled all that information in automatically itself. Okay, so now the point is in the station in ECNet 4 Pro. You can think of a station like a network. It's a big network hub. It's a big switch. So it can be transferred to any other place in the station. It's like a switch. You plug it in, take another wire, you can plug it anywhere else. So this includes other drivers and devices on those drivers. So the next step is we already configured the bacnet station to have its points to pull into ECNet 4 Pro. Now we want to talk to the modbus TCP network driver. So like the bacnet driver, we have the device on the modbus network, and it has a points section. Within the points section, there's all the devices that I had made, and each one of those has points in it itself. So for example, this is RL20, is the example we're using for the ECB 300s. These are the points I pulled from modbus. So they might look random, oh, what is 47,960? What is Boolean point 601? What is, numeric point 47,000? That is configured inside of Delta V itself. So this is a screen grab of the modbus port in the PK on our network right now with the configured modbus registers. You see 47,951 is the temp ref from this program. So we're basically setting up in ECNet 4 Pro to receive information or give information to the modbus registers. Now the tricky thing is about this system is that it's kind of a caveat, but these aren't real modbus registers. They're just points that ECNet 4 says, okay, it's number 47,000, whatever. What really does the conversion is the Fox that is associated with the station in the Jace. So Fox is Niagara's server, and that's what they can do some magic and just say, oh, this point right here, that is modbus register 47,900, whatever it is. That's the power of Fox. So I didn't configure Fox, Fritz didn't configure Fox. When you open a station, Fox is automatically enabled. It's the first thing that they set up on a station, the Fox server. That's the only thing. So these aren't really modbus registers, but you can think of them like that. Fox does the magic behind the scenes. Okay, so now we pulled in the bacnet points that we want to pull in from the controllers, and we pulled in the modbus registers that we want to pull in from the modbus register. And like I said, it's a big network. The station's a big network. So now what we're going to do is we're going to take the points from the modbus driver and point it to the points in the bacnet driver. The way you do that is, let's say this Boolean point 601, that translates to the damper command for the 4RL20 BE5. So what we do is we right click on it, we say link mark, and we are in the modbus TCP network PK controller points RL20. And then we go back to the bacnet driver 4RL20 BE5 points folder, db damper command, link from Boolean point 601. So now what that does is that says, okay, in the modbus TCP driver, I'm now configured to be 601. Whatever's in modbus register 601, that's my value. And then this says, okay, well then if that's my value, that's your value too. And that allows the program to respond to a modbus port. And so what you do with that information is you just like the out to the N3, that's just to finish up the connection. And now we get to the point where you can actually start to manipulate distech from Delta V. Now, if you, in this section here, make that a 1, that'll become a 1. That'll point to modbus register 601. That will point to the bacnet register for that particular device to be a 1, which will make in the program that block a 1, which will then respond to whatever we call the response.